Alrighty, so this is the start of part 2 of titrations. Make sure that you have your calculator, your reference table, your notes, and something to write with handy. So you do need a calculator at this point. So our first question is, what is the concentration of 600 milliliters of sodium hydroxide in which it takes 300 milliliters of 2 molar hydrochloric acid to neutralize? So I'm going to do that problem with you now. If you would like to go ahead and give it a shot on your own, I'm going to give you that opportunity to give me your answer. All right, so we're remembering our equation is MAVA equals MB VB. Okay, our molarity of our acid, I'm going to define every term here. Bear with me. Okay, so our molarity of our acid is 2 molar, because our acid is this hydrochloric acid up here. Our volume of our acid is 300 milliliters, according to the word problem. Ignore her, she's being a pain. And the molarity of our base, that's our unknown, it's what we're solving for. And our volume of our base is 600 milliliters. So when we set up this problem, it will be 2 molar times 300 milliliters. Whoops. Equals X times 600 milliliters. And if you do that correctly, you get 600 equals X times 600, and that means X would be a 1 molar hydrochloric acid solution. Okay, sorry, doing it all in my head. Of course, that one was super easy to do in my head. Alrighty, so let's try another problem. How many milliliters of 0.5 molar sulfuric acid is needed to neutralize 200 milliliters of 5 molar ammonium hydroxide? All right, I'm going to give you a moment to try this one on your own. Now, this one's a little different because H2SO4 is diprotic. So we have to double the molarity because the number of hydrogens produced is double, okay? So when we work this problem out, our 0.5 molar sulfuric acid solution is like having 1 mole of hydrogen ions. So when I work that out, I'm actually going to show this a little bit of a different way. I've got my 0.5 molar. I'm going to multiply that by 2 because it's diprotic, okay? And we're solving for X. And then we've got 5 molar ammonium hydroxide times 200 milliliters. So that means essentially 1X equals 1,000 milliliters. So X will equal 1,000 milliliters. Let's look at example 25. In a laboratory activity, 0.5 moles of sodium hydroxide is completely dissolved in distilled water to form 400 milliliters of sodium hydroxide. This solution is then used to titrate a solution of ammonium nitrate. Identify the negative ion produced when the sodium hydroxide is dissolved in the distilled water. Okay, you got this one. Give it a shot. Absolutely right. That would be hydroxide, negative hydroxide ions. Now, part B is the thing that's new. Calculate the molarity of the sodium hydroxide. Your response must include both the correct numerical setup and the calculated result. Obviously, this was from a Regents exam. Okay, now I just want to point something out. Just because we're working with acids and bases doesn't mean we're necessarily doing a titration. Here, we're asked to calculate the molarity, which we can do in a titration, but we're not given enough information to be able to do it. We have to use the good old molarity equals moles over liters equation here. So this would be 0.5 moles of the sodium hydroxide in 0.4 liters of solution. And we're doing that because our, remember, you have to use liters, and so we have to convert the milliliters to liters. So our answer will be 0.5 divided by 0.4, and that is going to give us 1.25 molar solution. Okay, let's try another problem. So this is a multiple choice problem. This came from an old Regents. I'm sorry, I apologize for Bessie. You just ate. Okay, example 26. So we're given information related to a titration experiment, and we're reacting sulfuric acid with potassium hydroxide to make potassium sulfate and water. This is a neutralization happening within a titration. It's giving us the volume of the sulfuric acid, the volume of the potassium hydroxide, and the volume, or sorry, the concentration of the potassium hydroxide. The piece of information that we have not been given is the concentration. So we're going to have to calculate that. So it says, based on the equation and the titration results, what is the concentration of the sulfuric acid? So I'm going to use MaVa equals MbVb. But before I do, I'm going to notice this is a diprotic acid. So I'm going to multiply my concentration by 2. So instead of just having x as my unknown, I'm going to have 2x. So to set this up, I'm going to have 2x, this is my unknown concentration, times 12, that is my volume. And now I'm going to do my side for my base. This is my, remember we're using MaVa equals MbVb. My volume of, or sorry, my molarity of my base is 0.16 molar times 36 milliliters. And when we work that out, that is going to give us a final answer of 0.24 molar. All right, let's try another problem. So example 27 actually has multiple parts. This is once again from a Regents exam. In preparing to titrate an acid and a base, a student puts on goggles and an apron. The student uses burettes to dispense and measure the acid and the base in the titration. In each of the two trials, 0.5 molar, I'm going to just go ahead and underline that, sodium hydroxide solution is added to a flask containing a volume of hydrochloric acid, solution of unknown concentration. Phenolphthalein is the indicator in the titration. The calculated volumes used for the two trials are recorded in the table below. So, first thing it says, write a chemical name for the acid used in the titration. Okay, what's the name of the acid used in the titration? Well, they tell us it's HCl. You go to table K, that is hydrochloric acid. Okay, let's do the next question. Using the volumes from trial 1, determine the molarity of the hydrochloric acid solution. So we are going to use the trial 1 data. This is our volumes. Here are our molarities. This is our base. Here is our acid. So MaVa equals MbVb. Give it a shot. Alrighty, so when I set this up, it is going to be x times 10.22 equals 17.03 times 0.5. Actually, I should have reversed those, but the math will work out to be the same. And my answer to that would be 0.83 molar. Great. Let's look at the next part. Based on the information given in the table, how many significant figures should be shown in the calculated molarity of the hydrochloric acid solution shown in trial 2? Oh my God, this is a throwback question. Okay, so we are multiplying. And let's see, what have we got? Well, trial 2. How many sig figs can we use? Well, my friends, we can use 3. Well, why can we use 3? Because the rule is lowest number of sig figs, and this has 3 sig figs, this has, whoops, wrong trial, this has 4, this has 4, 3 smaller than 4, so we can use 3 sig figs. Alrighty. 81. Identify one additional safety precaution the student should have taken before performing the titration. Alright, this is like a wide open question. What's one other safety precaution that student should have taken? Alright, if you said use gloves, or if you said carefully dispense the acid or the base, that would have been, or tie back their hair, any of those would have been a perfectly fine answer. Okay, let's try example 28. Here's another one. It's a multiple choice. I'm going to give you a moment to look it over and try to solve this one on your own. Alrighty, so this is a titration equation. Student completes a titration by adding 12 milliliters of sodium hydroxide of unknown concentration to 16 milliliters of 0.15 molar hydrochloric acid. What is the molar concentration of the sodium hydroxide? So we're going to be using MAVA equals MB VB, and I'm going to set that up down here. So let's first do our acids. So our base is our unknown concentration. Our acid, we're going to have 0.15. That's our molarity, times 16.0 milliliters, that's our volume. And then we have an unknown concentration of our base, and our volume of our base is 12.0 milliliters. When you work this out, you should have gotten choice 2, 0.20 molar. Alrighty, so thanks so much for checking out this quick video on titrations and how to do titration calculations. I hope that all of you have a great day. Thanks for tuning in to Periodic Perfection with Ms. Knoll. See you guys later.